That $40,000 GPU humming in your server rack is an expensive paperweight. It spends 85% of its lifespan doing nothing. You bought a supercomputer, but you really bought a digital traffic jam. This is the memory wall. It is the dirty secret hardware companies want to hide. In 2026, it is quietly choking the artificial intelligence industry. For a decade, tech giants poured billions into making processors faster. They built massive tensor cores to crunch trillions of numbers. Compute speed skyrocketed. But they neglected the pipeline feeding those cores. Processors still fetch data from memory, and that bandwidth has flatlined. Your premium GPU is stuck in Gridlock. It takes longer to move a number from high bandwidth memory to the core than it takes to actually do the math. Your massive silicon just idles. It waits. I will show you how new reasoning models push this limit to the breaking point in a moment. Stick around, because the physics of this bottleneck will blow your mind. Think about how an AI generates a response. Every time a model spits out a word, it loads its entire brain across the memory bus. It fetches billions of weights. The tensor cores inside your processor are starving for data. They blast through the math instantly. Then they sit around doing nothing while the bus struggles to deliver data. You are not paying for compute power. You are paying for wait time. The bottleneck is not the brain. The bottleneck is the tiny straw the brain is forced to drink through. Now add the massive KV cache into the mix. In 2026, we run heavy, long-context reasoning models. We ask these systems to process millions of words and remember everything. To maintain context, the GPU stores past tokens in the KV cache. This takes up an absurd amount of space. As the context window grows, the memory gets squeezed hard. It forces the system to swap data constantly. The memory bus gets choked out by endless traffic. Inference latency spikes, and your generation speeds crawl to a dead halt. The GPU stops acting like a highly advanced AI. It becomes a middle manager shuffling files between desks. It is inefficient and incredibly expensive. But a wild new hardware architecture coming online deletes this problem entirely. I will reveal exactly how it works in a moment, but you need to understand the roadblock. You might be thinking, just move the memory closer to the processor. We tried that with SRAM, which lives directly on the chip. It is blindingly fast, but takes up too much physical space. You can only fit so much on a silicon die before the chip becomes massive. If the chip gets too big, it becomes completely impossible to manufacture without serious defects. So we rely on high bandwidth memory placed next to the processor. But at the atomic level, next to is still way too far. The physical distance creates a massive hardware problem. Moving data across that tiny gap takes energy and generates massive heat. If you try to push more data faster across that distance, the processor chip literally melts down. You cannot outsmart the speed of light, and you cannot beat thermal physics. This physical gap is why your expensive hardware is bottlenecked today. But engineers are desperate. They engineered a backdoor to bypass the distance problem entirely. The old rules of chip design are being thrown out the window right now. Enter HBM4. They finally stopped trying to place memory next to the processor. Instead, they stack the memory directly on top of the logic die. It is true three-dimensional stacking. There are no horizontal gaps. There is no massive energy waste from dragging data across a board. The data drops straight down into the compute cores instantly. Compute in memory takes this a massive step further. What if you stopped moving the data entirely? Moving data causes the delay, so we simply stop moving it. These designs put processing units inside the memory chips themselves. Instead of sending heavy data to the processor, you send lightweight math commands directly to the data. The memory chip does the calculation right where the data naturally lives. It completely deletes the memory bus bottleneck. The Bugatti is suddenly driving on an open highway. This is exactly how the next era of AI hardware works. We are done building faster brains that just wait around. We are finally fixing the traffic jam. Thank you.